today is go through the homework that you guys had to do over the weekend, and let's see how you guys did. So the first one here, I'm going to write the word key up here. All right. First one says the Franklins inherited $3,500, which they want to invest for the child's future college expenses. If they invest 8.25% with interest compounded monthly, okay, determine the value of the account in dollars after 5 years using this formula. So they provided the formula for us. All right, where A is the value of the investment after 2 years, so that's the total amount at the end. P is the principal, meaning the original amount. R is the rate, and N is the number of times it's compounded. All right, so let's take a look at this. We have A equals, what was the original amount invested? So I'm hoping you put 3,500, parenthesis 1 plus. Now R, we're going to take our percent, 8.25%, right? Let me show you. And I want to change this into a decimal, so I'm going to move the decimal point twice, right? 1, 2. So that is the decimal I'm going to be inputting. So it's 0.0825. N is the number of times we're compounding. Monthly, there are 12 months in the year. Notice the N is also in the exponent. So it's 12. And did they give us time? They did. It said 5 years. So I'm going to plug 5 in here. All right, you guys, all we have to do now is throw this into our calculators. So we're going to do 3,500, parenthesis 1 plus fraction button. All right, try to get out of the glare there. 0.0825 over 12. Close the parenthesis, raised to the 12 times 5. All right, and now again, how much money? So we're going to round to the nearest cent. So this comes out to be $5,279.61. Okay. Which I did see a bunch of you got when I looked at the homework. All right, next one. Kristen invests $5,000. So that's going to be the P. All right. The bank rates 6%. That's our R. Compound monthly. So that's 12. To the nearest tenth of a year. Underline that. Tenth of a year. How long will it take for us to double? I'm going to circle that. Double. All right, let's throw some stuff into this. So we have P, the original amount is 5,000, right? 1 plus the rate, so 6%, right? We got to move the decimal back twice, 1, 2, so it's 0.06. Compounded monthly, so it's 12. 12 also goes there, right? Now, they did not give us the time, right? Because the question says how long. So that means T is going to stay in this question. For it to double, all right, if we started off with 5,000 and we want this to double, that means we want to end up with 10,000. All right, now we've got to solve this thing. Now, because the thing we're trying to find is in the exponent, we have to use logs to do this. So the very first step here is I'm going to divide by 5,000. Right? So the 5,000s here cancel. This is going to be 1 plus 0.06 over 12 to the 12t equals 2. All right, now I'm going to use logs right here. So I'm going to bring it over here so you guys can see it better. So I'm going to write the word log. Okay? The base is this whole thing here. So 1 plus 0.06 over 12. 2 goes there. Equals 12t. All right, so now I'm going to put this into my calculator. So I'm going to hit, where's my calculator? So I'm going to hit the math button, scroll up the log base, with the parentheses 1 plus 0.06 over 12, right? There's a parenthesis, and put the 2 there. All right, so now That's what this would be equal to. 138.9757216 equals 12t. But what would I have to do now? I have to divide by 12. So I'm going to divide this by 12. All right, and they want it to the nearest tenth, so that answer is going to be 11.6 for the second one. Okay, so you can see we're still using the same skills as we have in the last couple things. All right, Susie invests $500, right, so that's the P, the original amount, in an account that is compounded continuously. Continuously means we're going to use PERT, and if you notice, they gave it to us right there. There's the PERT. So you guys see the word continuously, you're thinking P-E-R-T, and the rate is 5%. Okay. How many years? That means we don't know the time, but we want the money to double again. All right, so let's set this up. So I'm going to write down PERT here. A equals PERT. Okay, in PERT, P is the original amount. So I'm going to put 500. Then you always keep the E. Now the rate. Interest means we're gaining money. So that means I'm going to put a positive 0.05 here. If they said we were losing money, we'd actually make that a negative 0.05. But the word interest means making money. So that's a positive. T. And we want to double our money. So if we started off with 500, we want the final amount to be 1,000. All right, guys. Again, the thing we're missing is in the exponent, so we're going to have to use logs to solve this. So what I'm going to do first is divide by 500. So that cancels. So 2 equals e to the 0.05t. Now, if it's an e base, we're going to use the natural log. So I'm going to write ln. You don't have to write the e there. It comes with it. It's built in. You put the 2 equals the exponent, 0.05t. Now, we got to get the t alone. So we're going to divide by 0.05. That cancels. Go to my calculator. So I'm going to do now, remember the natural log button is right next to the 4 right there. So I hit the natural log 2 divided by 0.05. And what do they want this to? How long would it take? How many years? 13.9 it looks like. So it's going to be choice C. So t equals 13.86294361, which is why I picked choice C. All right, next one, number 4. $5,000, so is invested. So that's P. Rate is 3%. Compounded quarterly this time. What is the value after 5 years? All right, and once again, they gave us the formula. So the original amount is 5,000, parenthesis, 1 plus the rate. 3% as a decimal is 0.03. Quarterly, how many quarters are in a dollar? How many quarters of a year are there? Well, 4. And then we do 4 also goes there because n is there and in the exponent. And did they give us time? Yes, they did, 5 years. So I'm going to put 5 there. So now I just go to my calculator. 5,000. 1 plus fraction button. 0.03. This time it's over 4. Raised to the 4 times 5. And 5,805.92 cents. So it looks like there it is. Choice C. All right, this was also choice C. All right, so that was the first half of the homework, basically, or the first page. And you notice it's a lot of the same thing over and over again. Let's look at number 5. If $5,000 was put into a savings account, okay, so that's P. The rate is 3.5%, so that's our R. Compounded monthly. Monthly means 12. How much money to the nearest 10 cents? Oh, so not the nearest cent, but the nearest 10 cents would be in the account after 6 years. All right, so what's the original amount? 5,000. parenthesis, 1 plus. It's 3.5%, so we're going to move the decimal point place back twice, so it's 0.035 over. Now, it's always over what we're compounding. It goes right here as well, so 12 and 12, and 6 years. All right, let's throw that in our calculators. They're off the last one. 5,000, 1 plus, fraction button, and what was the 0.035, over monthly, which is 12, and then close the parentheses, raised to the 12 times, and it was 6 in this question. All right, so I'm getting 6166.505. Now, they don't want us to round to the nearest cent. They want us to round to the nearest 10 cents, so that's why it's going to be choice D for this one. All right. 6. Determine to the nearest tenth of a year how long it would take for an investment to double at 3, so this is 3.75%, compounded continuously. What formula do we use for continuously? Well, that is P-E-R-T. A equals P-E-R-T. All right, let's fill this out. Determine to the nearest tenth of a year how long it would take for an investment to double. Now, they didn't give us an amount, so that means you can pick any number you want to start with. How much money do you want to start with? Let's say we have $100, so you can pick anything you want. So let's say I'm starting with $100. Right? We're going to do E. Rate, move my decimal point back twice, so I'm going to do 0.0375 T. But if I need it to double, I need to end up at 200. So you can pick any number you want if I don't tell you what to start with. Divide by 100. Bring it up here. So we end up with E to the 0.0375 T equals 2. Now, if the thing you're trying to find, if T is in the exponent, you have to use a log. And because it's E, we're going to use the natural log, right? You don't have to put the E, it's built in. Put 2 there again, equals 0.0375 T. So now I'm going to put natural log of 2 into my calculator and then divide it by 0.0375. So natural log of 2 divided by 0.0375. And does it tell us what to round to the nearest tenth of a year? So it's 18.48. So I'm going to put down 18.5 as the nearest tenth of a year. Okay, number 7. Carla wants to start a college fund for her daughter Lila. She puts $63,000 into an account that grows at 2.55% per year, compounded monthly. Okay. Write a function C of T that represents the amount of money in the savings account after it is opened. Okay, so we have to write a formula. So they want us to use C of T. So I'm going to write C of T equals. Now, what's always the first thing we write down? Good, the original amount. So she's investing $63,000, right? Now, did it say continuously in this? No. So we're not going to use E. I'm going to use a parenthesis 1 plus. Okay. Now, I've got to get the percent and move the decimal back twice. 1, 2. So it's 0.0255 over. Right? Now, what do they say it's compounded by? Monthly. So we'll put 12 there and a 12 there. So whatever goes there also goes in the exponent, T. So all they wanted you to do for the first part is come up with a formula. So we're done. Now, the second part, calculate algebraically the numbers of years. So that means we want to find time to reach 100,000. All right, so I'm going to do 63,000. 1 plus, I'm taking the formula we wrote to the 12T and set it equal to 100,000. All right. So step 1, I'm going to divide by 63,000. So that cancels. So now I've got 1 plus, we're going here, 0.0255 over 12 to the 12t equals. All right. So let's do 100,000 divided by 63,000. All right. So that's 1.587301587, right? Or you can leave it as a fraction, right? 100 over 63. So that might be even easier. Or 100 over 63. Instead of having to type all that in. All right, now we have to log it. I'm going to change colors. So I'm going to write log of this base, 1 plus 0.255 over 12, right? To the 100 over 63 equals 12t. Okay, so I hit math, go up to log, and we're going to put in that whole ugly parenthesis, 1 plus fraction button. Whoa, what did I hit? Let's just start again. Math, log, parenthesis, 1 plus alpha y equals 0.0255 over 12. And then you can grab that. Oh, I put it in the wrong spot. I'm just going to type it in, 100 over 63. Boom. All right, now that's not the answer because it said equal to 12t, so that means you have to divide by 12. So I'm going to take this now, divide by 12, and it wants it to, what is it here, to the nearest hundredth, right? And hundredth would mean 2 decimal point places. So it's 18.14. Would be the answer for that one, 18.14. Okay. Number 8. Judith puts $5,000 into an investment account compounded continuously. So I know I'm using PERT. Right? A equals PERT. Okay. Which approximate annual rate is needed for the account to grow 9,000 to this after 30 years? All right, so the original amount is 5,000. That's our P. Then we put E. Now, guys, what is the rate? That means we don't know the R this time. Time is 30 years. And we want to end up with 9110. So this is a little different. This time, instead of time, they asked for the R. We're still going to handle it the same way. If the thing that we need is in the exponent, we're going to have to use a log. So just like we've been doing, and I hope you're getting sick and tired of the same steps over and over again, I'm going to divide by 5,000. So then we have, I'm going to bring it here, E to the R times 30 equals 9110 divided by 5,000, right? And I'm going to try to keep it as a fraction, 911 over 500. It's a little easier to enter it to the calculator. All right. Now we're going to log it. So we're going to use the natural log, because it's E, of this guy, 911 over 500 equals 30R. And then to finish it, I got to divide by 30. Okay. So now, at the natural log, oops, fraction button, 911 over 500, right? So we got that, and divide it by 30. Okay, now, this is a decimal. We've got to find the percent. So that means we'd have to move the decimal point twice. So let me write that down so you understand. So I have 0.01999788266. Okay. To get a percent, we've got to move the decimal point twice. So it's 1.9999%. And that is the same as 2%. Okay. Two more. Let's see here. On the day he was born, a A boy's parents invested $2,000 in a bank to save for his college. He's going to do this semi-annually. How much will he have accumulated by his 18th birthday? All right, well, how much did he start with? Get my red pen. 2,000. 1 plus. Now, 6 3/4%, right? 6 3/4 is 0.75. So I'm going to move. Semi-annually is how often? It is twice. Okay. Now, whatever number you put here also has to go there. And 18th birthday means 18 years have gone by. So we just got to throw that in. So it was 2,000, parentheses, 1 plus 0.0675, semi-annually is 2, close it, raised to the 2 times his 18th birthday. And it's 6606.76. So it's money, 6606.76. And there we go, one more. And I hope you're realizing it's really the same thing over and over again. You're getting bored, and that's a good thing. Tonight's homework is much shorter. I think I only have 4 questions. So the first day is the big day because we have to practice. We have to practice. But let's see how tonight's goes. It should be a little easier. Sandra has a balance of $1,200 on her credit card. She is charged 18% annual interest compounded monthly. Assuming she makes no payments between now and then, how much will she owe after 15 months? All right. How much? She got $1,200. That's the original amount. All right. She's charged 18% annual. We're going to talk about that in a minute. Interest compounded monthly. So 1 plus 0.18 over 12. 12. How much will she have over 15 months? Now, see how it's annual interest? We need to know how many 15 months is of a year. Right? So, a couple ways you can do it. How many months are in a year? 12, right? So if I do 15 minus 12, right, that means we have 1 year and 3 months, right? And how many 3 months is how much of a year? It's a quarter of a year. Now, another way you could do it is do 15 divided by 12 in your calculator. See, it's 1.25. 1.25. So that's what you're going to plug in. So again, I did that because it asked about 15 months, but it's annual interest. So that's why I switched it. So now I'll go to my calculator. 1,200, 1 plus, what was the percent? 18% over 12. Raised to the 12 times 1.25. Let's see here. Compounded monthly. I'm getting 1,028. All right, guys. Now, that's how much, actually, I'm going to almost, it's not quite the answer, actually. That's how much is in the account, right? Just realized, right before I thought it was done, it said how much interest was she charged. Well, that means we still have to subtract off the 1,200 that was already in there. So if you subtract off the 1,200, that means this is actually the answer. Caught it. Sneaky little question. $300.28. And that's why I want you guys to notice what I did. I thought I was done. I actually always go back and reread the question just to make sure I completed it. And I noticed this was the first time that I'm like, whoa, hold on a second, Duffy. You didn't ask how much money was in the bill. How much interest was she charging? So that's why I subtracted that off. A little tricky. All right. So that was the first homework. I do have another one up there. It's only 4 questions. I'm hoping that you guys feel more confident. And then we'll practice one more time.